Okay, here's the program. Here's main. First it's going to say that it's starting, then it's going to immediately call API interaction. API interaction still runs on the main thread. It tells you that. It says we're going to sleep 3 seconds in order to prove it. Sleeps 3 seconds. Then it prints out it's starting the API calls, and then as soon as it calls this API call A with a wait, it seems to split off onto its own threads. So now, so then we'll see in the main thread, okay, I'm responsive, give me some input, and it's just going to wait, listen for input, and write it back at you. Just spit it back out at you, and so we'll have 2 threads going at this point. Then API call A is going to say, okay, I'm starting, I'm going to sleep 3 seconds, going to tell you that it's finishing. It's going to return a value. So you can see that this, in the method declaration, it's task, it returns an objective task type string, which is a weird kind of piece of syntax there, but you can see we're doing a wait on it, and we're capturing the result as API result. So once that's done, our API interaction, which is on the, we'll call it the API thread, it says, okay, here's the result from API call A. It prints it out. And now it says, okay, we're going to do some more API calls, B and C. And so API call B is non-blocking because we don't use a wait, we don't call wait, and we don't call result. So it's, and if you hover over it, there's a little green squiggly line, and you can see it says, because this is not awaited, executed of the current method continues before the call is completed. Consider applying a wait. But we're not going to do that, so we're going to see both B and C get kicked off at the same time. So we're going to see B starting, C starting. You'll see that B actually takes a little longer, so we will see C end before B actually ends. And we're going to we're going to wait, the API interaction thread is going to wait on C to complete on its thread. So there's a thread spun up for each of these, and what I finally realized is that it's not really using a wait that spins up a thread, it's calling, it's the creation of this task. Because in each of these API calls methods, we're creating a task, and that's what really, that's where multi-threading actually happens. And this could be rewritten fairly closely, at least, without using async, or a wait. I just realized today it's really just the tasks that invoke multi-threading, so to speak, which is why it's weird that this, well, no, I guess it's not weird, because that does call a task, create a task. Anyway, it's pretty confusing, which is why I did this whole thing. So both of those are going to begin at the same time. C is going to finish, then it's going to, this call is going to be complete. And it's going to unblock this method, so we're going to see this line, calling API is now done. We didn't wait on all of them to complete, that's okay. And then after that, B is actually going to complete. I wanted to test that just to make sure that the thread created when we call this method didn't somehow die when the calling method ended, and in fact it does not. And so some interesting things are, the main thread is what really controls the existence of the program, I'll say. So if you go in here while this is, so it'll block up to this point, but while this stuff is happening, calling these other threads, if you hit enter 5 times, or if you give it 5 lines of input, it will exit before any of these threads actually complete, which makes a certain sense, because if the UI, if the user says, I'm done, then we shouldn't have to wait for all this other stuff to happen. That is only true if it's servicing the UI. If it's, actually, now that I say it, if you're making a bank deposit and you say, okay, end the program, then you'd obviously want your little API calls to make the deposit to complete, or that maybe not the best example, but sometimes you would want it. So obviously in that case you'd have to somewhere down here make sure all your threads are complete before you end, but this program doesn't do that. So I'm going to do that example real quick. Start it. Now if I hit enter, you can see it's blocked, and now once that API interaction thread called await, then you saw the 3 times I hit enter show up instantly. And now all that stuff is done. Hit enter a couple more times, the program ends. So now this time I'm going to hit enter. So I actually didn't show what I meant to show. What I meant to show was I'm going to hit enter 5 times. And so this thing is going to exit, the program's going to exit before these threads are actually complete. We'll do that. I'm going to wait till, I'll just do it one time. Now you can see I hit enter enough to kill the program. I think whoops. Okay, yeah, that's not good. That's one of the annoying things about hitting enter a bunch of times, is sometimes if my program is highlighted down here, I'll delete some of my stuff. So some interesting things here are calling await, calling wait, or calling result. All kind of do the same thing. That's how you call it, isn't it? Oh, our result. There we go. Right, because this would be the task that it's returning dot result. So that turns into a string. If we take out async, this will now run synchronously. So the this whole thing will be blocked until API interaction returns. Hit enter a couple of times. I should be able to enter now, but we still can't. So now that it's oh right. Now the whole API interaction thread is done, and it got back to main. But if we put this all in a task, let's give it a shot. And just say static task, I think. And then that's it. Let's see what happens now. Alright, so yeah, it doesn't block. That early blocking does not happen. As soon as it makes this call, the thread is, there are 2 threads, and we don't have to wait for this right here blocking, because we're not on the main thread anymore. That statement is no longer valid, no longer true. So you can do multi-threading without async and await. I think async and await just give you more, just give you the control you need to do it properly. Undo all this stuff. So the last thing I'll say is that using await is really the right way of doing it. Using wait and dot result is not best practice. We're just doing some pretty straightforward test automation here. So we really want everything to run synchronously. But in general, using wait and .result can lead to deadlocks, and I don't understand that part of this language. But do more research before you use those.